Hello, welcome back, and today we're going to be doing weekly premium daily problem 253, meeting rooms 2. And so this problem is given an array of meeting time intervals, where intervals I start end, return the minimum number of conference rooms required. And so you're given some intervals where you have to have these meetings, and then you have an output. And so just looking at this example, so you have some meeting from 0 to 30, then you have another meeting from 5 to 10, so clearly this 5 to 10 is to be in a different room than this 0 to 30. And then you have another meeting from 15 to 20, which could be after this. So let's just draw these rooms. So let's just think about how we would do this with the rooms. First of all, we are going to have to sort the intervals, so that's going to be pretty straightforward, right? Because we have to look at all the times of the meetings in order. And how would you normally, think about how you would normally figure out how many rooms you need for a whole day, right? You just take every single meeting and you try to put it in a room, and then for the next meetings, you see, is there an available room? And if there's not, then I add another room, and then add another room, and then so on. So let's try to see what that would look like. So this is sorted already. So we're going to start with 0 rooms, right? And we're going to have a meeting, okay, 0 to 30. We don't have any rooms. So let's make a room. And let's just put in, the only thing we really need for a room once we make a room is when it's going to be free again, right? So this room, this first room is going to end at 30. Okay. Then we have another meeting, starts at 5. Well, do we have a room that is available? No, we don't, right? Because this one ends at 30. So then we put another room, and that room ends at 10. And then we go to the next meeting and we say, okay, well, there's another meeting that in here that starts at 15. Do we have any room that ends before that? Yeah, we do. So we can use this room again, right? And then we're just going to update when it ends. So it's going to end at 20 now. And so you can see we only use 2 rooms for this example. So that's going to be kind of what we're going to be doing. We're just going to be adding rooms if we need to, and if there is an available room that ends before we have another room to put in, or before we have another meeting, then we're going to be able to reuse the room. Now let's think about one more thing. So let's say we just have all these random rooms in some order, right? So let's just say we have 3 rooms. One ends at 20, one ends at 100, one ends at 60. Okay? And let's just say we have some random meeting and it's going to be at, I don't know, 70. How would we prioritize looking at these rooms? Which room do we want to look at first, right? So the way we're going to want to do this is we're going to have some container for these rooms, and they're going to have some end times. What we're going to want to do ideally is check the rooms by order of when the meeting ends earliest, and that's going to give us, if we have a room and it wants to start at 70, and if we have these rooms, if the room with the earliest possible end time does not work, right? So this first possible end time does not work, then we know that no other rooms will work either, right? Because this is the first available room. So if this room is not available, then these won't work either. And so that's what we're going to do. We're going to have these rooms, and we're going to have them sorted in some way by the first available end time. And if there is no room that's, we're just going to check, okay, is this room that's sorted by the first available end time going to work for the new time we need to put in? No. Okay, well, in that case, no other room will work because this is the first available room. So if the first available room doesn't work, then the ones available later won't work either. Okay. And then what we're going to basically do is we're going to say, okay, is this first available room, it doesn't work? Okay, well, then we need another room, so we're just going to add another room, and we're going to say it ends whenever this ends, let's say 120 or something. And then we're going to, so we need this sorted container, and we need to keep checking the first available room, and we need to double check, is that available or not? And then how do we know how many rooms we need? Well, that's pretty straightforward, right? We can just keep taking the length of this data structure that holds the rooms, and then we can just take the maximum of what it is at any point. So even though we can take rooms and take them in and put them out and whatever, we can just take the maximum at what this is at any point, and that's going to be your output. So let's say these meetings all end even, and then I have some other meeting at, let's say I have some other meeting at 200, even if I get rid of all these rooms, I can just put in a new room again, and I could say 200, and then I could put 200 in here, and then I can put another room and whatever. But our output is going to be what is the maximum. Okay? So hopefully that makes sense. And so let's try to code this up, actually. So first thing we're going to do is we're going to need to sort the intervals, like I said, because we do need to check in order. So intervals sort. And then we're going to think of what data structure do we need to keep track of to keep track of the first available room and all the rooms. And because we just need the first available room with the smallest end time, we're going to actually use a heap data structure, right? Because we don't really care when these end, we just need the first available room. Okay, so we're going to use a heap. So we'll just have heap equals something. Then we're going to have an output variable, right? And we're going to default it to 0. And then we're going to go through all the intervals, right? So for interval in intervals. And we're going to think, what are we doing? Well, for the interval, the left is the start time and the right is end time, right? So remember, we're going to need to check, do we have an available room? So we're going to say if heap, and heap 0 is going to be the first item in it. And we're only going to record in the heap the end times, right? Because that's all we care about. So if heap 0, and then what do we need to do? We need to say if heap 0 is less than or equal to. I'm not sure actually. So we'll double check this, but I'm not sure if if something ends at 30 and then you need another reboot at 30, if that's how they want to handle that. They don't really say, I don't think. So we're just gonna say that we're just gonna try one of the two, either equal to or not, and then we're gonna try it out, and then if it gives us the right answer, then that's what they wanted. So if heap's 0, so for now let's just say this. If heap 0 is not, probably, I think. So if heap 0 is greater than interval, and so heap 0 is going to be when the first room is available, right? Okay. So if heap 0 is greater than interval, and then we want the starting time, right? So that's going to be 0. Then what we need to do is remember, none of the rooms are going to be available in that case. So what we're going to do is we're going to need to push this onto the heap, right? So, and then we're just going to, and remember, we're going to be pushing on the interval end time because that's what we care about. Okay, so interval 0. And then, so we did that. Now, how do we pop intervals? That's the other thing what we need to do, right? So pretty much what we need to do is, so we have this else case, and if the first available room does work, what we need to do is we could do one of two things. We can either pop it and then push it back on, or we can update the value and then do a heap sort, or just heapify it again. So that's one of the two things we can do. Okay, so let's just do the heap pop and the heap push, because that's going to be 2 log n, which is faster than log n, or which is faster than n if we do a whole heapify again. So that's what we're going to do. So the second case means that the room is fine. So we're going to heap pop heap, get rid of that room, and then we're going to add another. It's going to be the same room, but we're just going to change the value. So we're going to heap pop heap. Now we're going to heap push heap interval 0. Okay? So hopefully that makes sense, that if there is no room, we need to heap push, and if there is, then we need to heap pop. So actually what we could do is we could reverse it a little bit to get rid of this line being duplicated, but we can leave it as is. It's not a big deal. Okay. And remember, what we need to do after this thing is we need to check, is the number of rooms we have greater than res, right? So res equals max heap. And then we just return res here. And I think that's actually it for this problem, so let's just try to run that. Let's see here. If heap, okay, so that means the room isn't available. Okay, so in this case, what we need to do is we actually do need to do this. Like I said, you can definitely clean up this code a little bit, but this should work. Because what we're doing is we're saying there is no available room, so this would be the case. We can only pop if there's something to pop. Let's take a look. So let's actually go through this example to see if we did something wrong. Because this first one is failing, right? So we're going to have a heap, and then we're going to have these intervals. So for the first case, we are going to, so there is no heap, and there is no heap. So we're going to push. So actually, instead of writing it all out, we can just print the heap, right? So let's just do that instead. Take a look what it looks like. Okay, so first it's empty. Oh, so that's what we screwed up. So we need to actually push, instead of interval 0, we need to push interval right at the end time. So that is what it is. And let's try to submit. Okay, looks like it works. And so that's it for this problem. Now let's figure out what the time and space complexity is for this one. Okay, so time-wise, what's the worst case scenario? Well, the worst case scenario is all of our rooms are not working, right? So we can have some case like, let's say we have some rooms and we always have, or for these intervals, we always have to keep adding another room, right? So if this is like 0, 1,000,000, or like 1,000, right? This is 1, and then, you know, even bigger and even bigger and even bigger and so on. Then we're just gonna we're gonna have to make a new room for each one of these intervals. So worst case scenario, all of these take too long, right? And so that would be length of intervals. If all of these take too long, we're gonna have to keep pushing them onto the heap, right? So it's gonna be n log n. Right, so we have to push them on if they don't work, otherwise we have to do this as well. So I think actually either way it's going to be n log n, because no matter what, we're doing either a heap push or, yeah, we're always doing a heap push because we're always pushing this interval. So actually, regardless of the worst case or not, we're going to do n times these heap pushes. Okay, and then here, once again, so now the worst case scenario, our heap would hold every single value in the interval because we're never going to be able to pop. Like this is if a room is available. But let's say a room is never available. Well, then what we're going to have to do is we're going to have to keep pushing, and so this would be big O of n, where n is the intervals. If our intervals all require a different room. Okay, so that's all for this problem. And if you liked it, like and subscribe, and I'm going to continue making more of these in the future. So thanks for watching.